Welcome to Chapter 4, P1, Cambridge A-Level Mathematics. And I want us to quickly look at the image. This is the Wiener restaurant. It is a German meaning Viennese giant well. Originally constructed in 1897. In 1897, this particular giant well originally constructed in 1897, and it is one of the most frequently visited attractions in Vienna, Austria capital city. The well is 64.75 meters tall and was the world's tallest Ferris well from 1920s until around 1985. So the well turns through an angle of approximately 85 degrees or 1.5 radians according to the calculation given by world-best mathematicians. So it is driven by a circumferential cable which leaves the well and passes through the drive mechanism under the base. So exactly what we are covering in this video. This is actually one of the shortest topic in A-Level Maths Cambridge edition. So we are going to look at various methods on how we can convert radians to degrees to radians. Understand also the terminologies of a radian and the use of their relationship between a degree and that of radians. We will also look at the formulas like S equal to R theta, and we look at that relationship of area to be equals to half R squared theta, and theta is going to be measured in radians. And in solving problems concerning the arc length, we are going to also look at area of a sector of a circle, and we did also this in IGCSE when we started looking at circles, circumference of a circle. We also look at the chord of a circle. We also look at how to find the sector or area of the sector and all that. So this is what we will be looking at in this chapter, circular measures. I hope you guys are ready for it. So let's get started. So among the objectives that we are looking at is what I already mentioned. So we are going to look at understanding some of these definitions of the radian and their relationship. They use using the relationship between radians and degree. And we are also going to focus on this formula, S. As you can see, the formula we have, S is equals to R theta. And we will also look at this. This area is equals to a half R squared theta, where theta is measured in radians in solving problem concerning the arc length and that area of a circle, or the sector area of a circle. Now, before we start, or before you start, you should know how to find the perimeter and area of the shapes. This is something you did in IGCSE, year 11 and year 10. By now, you should be able to know how to find the perimeter and area of different shapes. Again, in math, generally, what is a perimeter? A perimeter is nothing but the total distance. So we are looking at the total distance around the outside of maybe a 2D shape, like rectangle, a square, a triangle, a circle, among others. So it is simply the total distance around the outside of that shape. So think of it as the length of the boundary of the force around the shape. So when we talk about the perimeter and the area of the shapes, you think about the length of the boundary of the fence around the shape. Example, we can talk about if a rectangle has a length, we can take a rectangle. Let's say a rectangle has a length of, I can take just something like maybe 6 centimeter. If I take 6 centimeter and maybe the width, if we say it has got the width of maybe 4 centimeter. 4 centimeter, and we want to find the perimeter of this. So it becomes 2, right, multiplied by 6 plus 4, right? It will be 2 multiplied by 6 plus 4. Such that this becomes 6 plus 4 is 10, and 2 by 10 gives you what? 20 centimeter. So it is as simple as that. Then we can now square all sides are equal, right? So maybe side is 5, so it means we can take 4 by 5. So 4 multiplied by 5 gives you also 20 meters, right? 20 meters. So we can do the same for triangle. We can do the same for circle. Take for instance, you have perimeter is given in this example. We have 10 plus 4 plus 4 plus pi times 10 divided by 2 will give you this. And we will look at how we can now find the area and find the perimeter of different shape in now recalculation. Again, in this number 2, we are supposed to find arc length and area of a sector of a circle. And from IGCSE 10, you already know the formula of finding arc length. Theta divided by 360 times pi d will be equal to the formula that we will be requiring in terms of looking for the arc length. Again, area of a sector is theta, the angle, the included angle in that shape, divide that by 360 degrees multiplied by pi r squared. We will use this formula in finding the area of a sector. We can look at arc length. Let's say the angle is 110 degrees. So we can take 110 degrees divided by 360 multiplied by pi times 10. If you put this in your calculator, you will simply get the answer 9.60 centimeter. And this is what we are going to be looking at in this particular topic. So you can try yourself to see if you are able to find the perimeter and the area of the shape. This is conceptual understanding, right? It is what you know. Try to test your understanding, and from there you will be good to go in the rest of the topic. Now we are here on terminologies. Radians. There is more than one way to measure an angle, right? So far as you are probably using degrees. So in this particular topic or chapter, it introduces you to radians, right? So 1 radian is the angle subtended at the center of a circle. So radians are by an arc length that is given by that r. That is, we say that when a sector is drawn with an arc length equal to the radius, then the sector angle is nothing but 1 rad. It is nothing but 1 rad. Right. For the circle shown, circumference will be 2 pi rad, like you have seen. The circumference is simply 2 pi rad. So we can take 2 pi multiplied by arc length of PQ up to there. This is Q. So if we multiply that, we will simply get 2 pi multiplied by 1 rad. So that is going to be 360 degrees. So if we have 360 degrees, this will be equal to 2 pi. And it is 2 pi rad. So we will look at this, and also how now we can convert from degrees to radians and convert from radians to degrees. Again, in degrees, 0 degrees is simply 0. 30 degrees is pi divided by 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. And 360 degrees is 2 pi. So we will look at how these are coming about and how we can convert either from degree to radians or from radians to degrees. The first example, convert 165 degrees to radians. So we simply take 165 that you have. This is 165. 165, multiply that by pi over 180. So you will get 11 pi over 12. So this gives you 2.88 radians to three significant figures. If we look at the second example, we have to convert 2 pi divided by 3 rad to degrees. So this becomes 2 pi by 3, multiply that by 100 over pi. 100 over pi. This gives us 120 degrees. So if you know what we are doing here, if we want to convert to radians, you multiply by pi divided by 180. And if you want to take it back to degree, you take 180 divided by pi. So it becomes the inverse, or you take the reciprocal of that function. So pi over 180 will give you radians. And then 180 over pi will give us degrees. So we are going to be manipulating this. So now let's quickly look at exercise 4.1. Exercise 4.1a. We are supposed to convert each angle to radians, giving your answer in times of pi. So again, we know the formula for converting to radians. We know that radians is going to degree is nothing but this will be equal to the degree, multiply this by pi over 180. So here we have 15. So we are going to have this is 15 degrees. So it is equal to solve this, we are going to have 15 degrees, right? Multiply this by pi over 180. Just plug that in your calculator. You should be able to get 15 pi. So this is 15 pi over 180. And you can simplify 15 pi over 180 to give you pi over 12. Correct. And you can do the same. Let's take B. B, you have to convert to 25 degrees. So 225 degrees, multiply this by pi all over 180. This gives you what? 225 pi. 225 pi divided by 180 is nothing but 5 pi over 4. 5 pi over 4. We can do the next one, C. If we do C, you have 135. 135 degrees, multiply this by pi all over 180. This is equal to 135 pi all over 180. And you can simplify that. Use your calculator. You should be able to get 3 pi over 4. 3 pi over 4. And you can see it is as simple and straightforward. Test your understanding in question D, E, and F. And then you can check the, try to check the answers in the link provided. Again, if you have the P1 textbooks, you can as well confirm with your textbooks. You have the answer. Again, let's look at number 2. Convert each angles to radians. So number 2, we are supposed to convert each angle to radians. So again, just like before, we simply interchange. Instead of pi over 180, we have we have now 180 over pi, right? So so number 2 is just like number 1, because number 1 you have to convert each angle to radians, and number 2 convert each angle to radians. The difference is that in question 1 we converted to radians, leaving our answers in terms of pi. But in question 2 we are supposed to give your answers to 3 significant figures. This means that we need to give the answers in terms of decimals. So let's take the first one. If we convert 25A, so if we convert 25 degrees to rad, it will simply be 25 multiply this by pi over 180 degrees. So you try to find from your calculator what is pi over 180. You should be able to get terminating decimals like 0. So we are going to have 25 multiplied by 0.017453. So we can take that. When you multiply this, you should be able to get 0.017453 by 25. This will give you 0.4. So this is 0.436. So 3 significant figures are rad. Right. And we can do the same in the second one, be 100 degrees. 100 degrees, multiply this by pi over 100, pi over 180. This should be able to give us 1.745 rad. And you can do the same for the rest of the exercise. Confirm your answers in the link below this video. Let's look at question 3. We are supposed to convert each angle to degrees. Again, now we take the inverse. We just, instead of pi over 180, we take 180 divided by pi. So in this case, we have pi, the first question A, in question 3, pi over 10. We have pi over 10 right here. So pi over 10 multiply by 180 divided by pi. So notice what happens here. We have pi and pi, so that cancels out. So you will have 180 divided by 10, you will get 18 degrees. So that is very simple. You just cancel this and divide 180 by 10, and that is the answer. Do the same for B. B, you have 7 pi over 180. 7 pi will be 7 pi over 180. Multiply this by 180 over pi, right? So we are going to have, if you simplify this, you simply get 7 degrees, right? 7 degrees, isn't it? 7 degrees. Because pi cancels, and then you'll have 7 by, you cross multiply each of these, and then you are able to solve. So basically solving and converting these are very simple and straightforward. These are cancels. You cancel this pi, and we are left with 7. So the final answer there is simply 7 degrees. Now let's look at arc length and sector area. Arc length and sector area. So using radians as the angle of measure gives us simple formula for the length of arc and the area of a sector. From the diagram that we can see that if theta is measured in radians, then the arc length is simply S, like you can see here. So S is equal to theta divided by 2 pi, multiply that by 2 pi r, where 2 pi r, circumference of the circle, with radius r. So you need to remember that the angle for a whole circle is nothing but 2 pi rad. Also, area of a sector is given by this formula. area of a circle with radius r will be given by half r squared theta. So arc length is nothing but s equals to r theta. Sector area or area of a sector is a half r squared theta, where theta is measured in radians. So you need this formula in your fingertips as we dive into examples and problems relating to the same. Look at this example 3. You are to find, you can see the shape OAB. OAB is a sector of a circle with center O. And the radius, you can see the radius is 8 centimeters from 0 to B. So we are supposed to find the area of a sector. In terms of pi, you simply use the formula A equals to half r squared theta. And the radius is 8, right? So you simply take 8 squared multiplied by half times 2 pi over 3 as it is given in that center. You will get 64 pi over 3. B, find the perimeter of the sector. We did perimeter earlier on. So you simply take S equal to R theta, where R is 8 and 8 centimeter. Multiply that by 2 pi over 3. You get 16 pi over 3. So this is very simple. So you can attempt this exercise 4.2. They are all very simple exercises, and I have included the solutions, the answers, in the link below this video. Let's look at some other further problems involving arcs and sectors. When solving problems involving compound shapes, you may also need to know and be able to use other results you have already made. So this will include those now going back to Pythagoras theorem, a squared plus b squared equals c squared. Pythagoras theorem, right? So right angle triangle, when we go to trigonometry, we know sine x is equals to opposite over hypotenuse, cos x is adjacent over hypotenuse, and tan x is opposite over adjacent. And we are going to apply all this. Opposite over hypotenuse, adjacent over hypotenuse, cosine, and the tan will be opposite over adjacent. If you draw a shape like this, right? So this is the hypotenuse, then we have opposite, and then we have our adjacent. So look at this. Sine rule, you need this rule. You can check your trigonometry table. You have A divided by sine A is equals to B divided by sine B, and that is equal to C divided by sine C. Hence, if we go to cosine rule, A squared is simply B squared plus C squared minus 2BC cos A. You can watch my previous video on how we derive this formula, derivation. It is a year 11 specification. Here in year 12 and in this particular specification, we are not allowed to derive this formula. So again, area of a triangle rule, area is equals to half ABC, AB sine C, AB sine C. So we need these formulas now in the next exercise. Look at example number 5. In the diagram that you have seen, BD is the arc. BD, you can see BD. So this is the arc of a circle with center C and radius 20 meter. You can see 20 meter. Angle BCD, angle BCD is given as 2 pi over 3 rad, right? So AB and AD are tangent to the circle. And you know what tangent means? It means the line touched the curve at one point. So this AB and AD are tangent to the circle at B and at D. You can see they touch the curve at B and at D, right? So we are to show that AB is equals to 20 root 3 centimeter. That is the first thing. So let's start with this problem. Now we have conceptual understanding. What were you given? What are you given? What do you know? You start from what is known to what is unknown, right? So we have angle. So let's start A, solving the first equation. We are to show that AB is 20 root 3. So let's look at angle BCA. Look at angle BCA. Angle BCA. Angle BCA, we are given angle. If we look at BCA, BCA will be pi over 3. But if we look at BCD, it is 2 pi. So if this is 2 pi, BCA is nothing but pi over 3. Pi over 3, right? So by the rules of trigonometry, if you look at this shape, this is tan, right? Tan. Then you can go back here. Tan takes you to opposite over adjacent, right? So this is tan. We are looking at this shape. So it implies that what we have here is simply tan of what? Tan of pi over 3 to be equal to AB, this shape AB, right? Divide that by 20, and we know 20 is what? The radius. Divide that by 20. So if we divide this by 20, this is AB. We divide that by 20. So finding AB, it will simply be what? 20 tan of pi over 3. You can plug that in your calculator and you should be able to get AB is equals to 20 root 3 centimeter as required. We were to show that is 20 root 3. So if you plug that in your calculator, you should be able to get that. So let's look at question B. We are of the shaded region. This side, the shaded region, the area of the shaded region, all these sides, is 400 root 3 minus pi over 3 centimeter. Okay, so let's look at it together. Conceptual understanding. So what were you given and what are you looking for? So now we have shaded region. So shaded region or shaded area is nothing but 2 times area of a triangle ABC. So this will be 2 multiplied by area of a triangle. So we look at area of a triangle. This sign represents triangle ABC. Then we subtract this by the area of what? Sector. So you will look for area of sector, and in this case, sorry about that, DCB, DCB, DCB. CB, area of a sector and area of a triangle. This is a triangle, and then we look at this sector, this region. So what do you know? We know that, you can write here, we know that area of a triangle is usually a half base times height. So area of a triangle will be a half base times height, right? And we also know area of a sector is a half r squared theta, right? So the shaded area, when we look at this area, this triangle, so we already have 2, so it is 2 multiplied by area of a triangle, which is 20 root 3 that we got in A. 20 root 3, right? So if we have that, multiply this by area of a sector. So we are going to multiply by 20 again, minus a half. Now r squared in this case is 20 squared, so it is multiply this by 20, square this, times theta, and our theta in this case is 2 pi over 3. 2 pi over 3. Now we can simplify this. If we simplify 2 by 20 root 3 by 20, we should be able to plug that in your calculator, 400 root 3. This is 400 root 3 minus this side, we are going to get 400 pi over 3. Pi over 3. And we can simplify this expression by factoring out 400. So we have root 3 minus pi over 3 centimeter, and this is given in this question as required answer. Now look at C. Find the perimeter of the shaded region. So the perimeter of the shaded region, we can call it P, is equal to AB plus the arc length of BD, the arc length of BD, and plus CD, the arc length of BD. And what is AB? AB is 20, we got 20 root 3, plus the arc length is nothing but 20, multiply that by the angle 2 pi over 3, plus CD 20 root 3. 20 root 3. When you simplify 20 and that 20, that should be able to give us 40 root 3. When you add that up, plus now 20 times 2 pi over 3 is 40 pi over 3 in centimeters. We need to leave our answers in exact form, so leave your answer this way. And you can confirm what we have done. This is the answer, 40 root 3 plus 40, that is 40 root 3, and then plus 40 root 3. Yeah, 40 root 3 plus 40 root 3. Okay. Like I said from the beginning, it is a very short topic. So look at example 6 and try to follow through. It is as simple as the one we did. And then try the exercises. Exercise 4.3 and check the answer in the link below the video. And I have also included exam style questions for your practice. And you can see that will be the end of this topic. We can look at a brief summary of what we have done. We have looked at radians and degrees. At 360 degrees, we give you 2 pi rad. And we know to convert from degree to radians, multiply by pi over 180 And to go back from radians to degree, multiply by 180 over pi. And you should be able to get all the summaries that I have indicated in the table. Arc length. So we have arc length. Arc length and the area of a sector is given as 2 pi rad. And arc length is 2 theta. Theta measured in rad. And area of a sector is a half r squared theta. And this will be the end of our class, end of chapter 4. I want to believe you have learned. Try to do practice. Practice makes permanent, not just perfect. See you in the next video.